Hey, physics class, I'm going to take you through progressively more and more complicated series and parallel circuits and show you how to compute their equivalent resistances. I'm just going to leave the battery out because once you find the equivalent resistance, then, calculating current and stuff is it's pretty basic. So this is just going to be about the resistors. So I'm going to start by just having one resistor, then I'm going to build it out and build it out and build it out. So let's start. All right, so let's just have ourselves a battery. All right, don't need to worry about the voltage, and we'll just put a resistor on it. Just one resistor, and I'm going to go ahead and label it. I'm going to name it. We'll call it R1. That would be resistor 1. And then I have to give it a resistance. So let's just start basic. I'm going to just make it 10. Okay. So we've got resistor 1, and its resistance is 10. Obviously, the resistance of the entire circuit is 10 because there's only one resistor in it. So let's go ahead and make an addition to this. So if I were to put a resistor right here, that can be resistor 2, and it can have a resistance of 20. So the first question is, are these resistors in series or are they in parallel? And here's how you're able to tell. If they are in parallel, you have a choice about which one to go through. If they are in series, you can't help it. You must go through both. So, as we're analyzing this, we just got to look and say, if I start here and I end there, do you have to go through R1 and R2? Or do you have a choice about which one you can go through? Well, looking at this one, you have a choice. You can start, and then when you get to this little fork here, you could turn right, and then right again, and just go through R1 and skip that entire extra leg, or starting here, you could choose to go straight and then complete the course. You have a choice between resistor 1 and resistor 2, so they are in parallel. So let's go ahead and do the math on that one. That's going to be the total resistance is equal to 1 over resistor 1 plus 1 over resistor 2. So a tenth plus a 20th. Let's just make these have a common denominator. I mean, it's, you know what? This is stupid. I'm going to do this with decimals. This is 0.1 plus 0.05. So it's 0.15. Oh, wait, no, that's the reciprocal. So the reciprocal of 0.15. This one, it's going to need a calculator. Give me a sec. Oh, my phone's dead. All right, so I think I am going to have to do this with fractions and also charge my phone. So 1/10 is 2/20. So 2/20 plus 1/20 is 3/20, which means that the total resistance is the reciprocal of 3/20, or 20/3, which is 6.67 ohms. Okay. So one thing that's worth pointing out, the resistance of the two of them is smaller than the resistance of either. And there's actually a nice way for you to kind of understand why that is. Let's just say that this was the entire circuit, just one 10 ohm resistor. If we add a 20 ohm resistor, did we make it easier or harder for electricity to get through the circuit? Now, I know you might be tempted to think harder because we have all the difficulty of 10 plus and the difficulty of 20. You don't, though. You have the difficulty of 10 or the difficulty of 20. And in this particular case, if you have the 10 and then you, okay, remember before we had the easy road and the hard road? 10's the easy road, 20's the hard road. You still lighten traffic on the easy road if you add another terrible lane, right? So, yeah, the resistance is going to end up going down. Okay, well, let's go ahead and make this just a bit more extreme. I'm going to add on another resistor, and I'm going to do it right here. All right, so this is going to be resistor 3, and it is going to have a resistance of 30 ohms. Okay, so I've got resistor 1, it's 10, resistor 20, I'm sorry, resistor 2, which is 20, and resistor 3, which is 30. Okay, what's the total resistance now? Well, here's where we kind of get into some order of operations thing. You have a choice between R1 and R2. Do you have a choice between R1 and R3? Well, yeah, you can take a path that takes you through R1 and not R3, and you have a path that will take you through R3 and not R1. But do you have a choice between R2 and R3? Is there a path you can take where you will go through resistor 2 but not resistor 3? Or resistor 3 and not resistor 2? Turns out that there is no such path. Resistor 2 and resistor 3 go together. They are in series. If we were going to do this almost like in an order of operations kind of a sense, using the words and or, I would write this. You can go through R1 or R2 and R3. Now, depending on how you parse that sentence, you may end up understanding this a little differently. So if it were R1 or R2 and R3, that sounds like you have a choice between R1 and R2, and then you must go through R3. That's not the situation that we're in. We are in a situation like this. R1 or R2 and R3. And that's the one that we've pictured there. In this particular case, you are going to need to break down the circuit into parallel and series arrangements and you need to respect a kind of order of operations. So just like I've put parentheses on the and here, you can kind of make sense of this almost like you can simplify an expression in algebra with multiplication and division. So I'm going to redraw this circuit real quick. Bear with me. All right, so we got R1, R2, and R3. So here's the first point. Are those the same circuit? Yeah, they are, but do they look like it? So here's one thing that's kind of funny. Before, R1 and R2 were in parallel. And in fact, even geometrically speaking, they're parallel. But check this out. I've now drawn R2 and R3 to be geometrically parallel. But are they in series? Well, here's how you determine that, right? It's like this. They're in parallel if you have a choice, and they are in series if you must go through both. If you start out this way, you have a choice between R2 and R1. They are in parallel. If you choose R1, then you complete the circuit and you're done. If instead you go straight, you have this choice between R1 and R2. If you choose R2, you no longer have a choice about R3. R2 and R3 are in series. Okay. So if we were to set up the math for this longhand, it would be absolutely maddening. It's a lot easier to break things down step by step. So the first thing that we're going to have to do is to combine these two in series. And hopefully I can explain why that is, even in just a series of images. Let's say I were to just redraw that. I'm just gonna move them a little bit closer to each other, like this. All I did was no, wait, I had that right. All I did was scooch them together. Just push them a little closer together. All I did was make that wire longer and that wire shorter. Okay, so if I were to, maybe heat them up a little bit in the middle there and push them together a little bit harder, I might even end up with something that kind of looks like this. Okay, it almost just looks like one resistor, doesn't it? Well, if they are one in front of the other like that, it should be pretty obvious that I should add them up first. So if I look back on the last page, I find that the values for R2 and R3 were 20 and 30. And because these are in series, and in series, total resistance is equal to just the straight up sum of the resistors, then this thing has a resistance of 50. In other words, going through a 20 and then a 30 is equivalent to going through a 50. Okay, so what I can do is I can actually just take this and redraw that original circuit, but with this in it instead. And that looks kind of like this. So I've got a 10 and a 50 in parallel. And in order to add up resistors in parallel, I need to do 1 over the total resistance is equal to 1 over 10 plus 1 over 50. So 1 over 10 is 5 over 50. So this is 5 fiftieths plus 1 50th. That is 6 50ths. That means that the total resistance is 50 over 6, which is 8 1/3. 50 over 6, because 48 is 8 times 6 plus another 2 is 1/3. So it's 8 1/3. Okay, so that would be the total resistance of that circuit right there. Okay, so that one was just a baby step. Let's go a little higher. Let's go up a bit higher now. Okay, so I'm going to give myself a lot of room here. So got my battery, and I'm going to start out like this. Okay, so resistor 1, resistor 2. Are they in series or are they in parallel? Okay, well, they're in series because you have to go through them both. All right, now let me add some wrinkles. Here's resistor 3 and resistor 4. Are they in series or in parallel with each other, 3 and 4? Well, they're in series because you can't go through 3 and then not go through 4. But what about this series and this series? Well, see, you can choose the black one or you can choose the red one. You don't have to go through both of them. However, if you do choose the black one, you have to go through both. Or if you do choose the red, you do have to go through both, but you don't have to go through both the black and the red. Does that make sense? So we've got R1 and R2 in series and R3 and R4 in series. But the R1, R2 series is in parallel with the R3, R4 series. Let's go ahead and do the math on this one. I didn't actually give them any values, so let me do that. This can be 100 and 400, And this one can be, oh, let's say 200. Oh, I should have written it in red. 200 and, oh, this one could be 200 as well. Okay, let's do the math on those. So if you were to take the black way, you'd run through a 100 and then also a 400, which means you could redraw this like this. A 500. Just replace the 100 and the 400 with a single 500. Now, if you were to take the red one, you'd be doing a 200 followed by a 200 in series. They just add up, so that would be 400. Do you see how that breaks down? A 100 followed by a 400 gives you a 500. That's the black way to go. The red way to go is a 200 plus a 200. That gives you a 400. So you have a choice, 500 or 400. It's just that your 500 was a 100 and a 400. Your red choice was a 200 and 200. If I were to write this out grammatically, I would write it like this. 100 and 400 or 200 and 200. So this 100 and 400 turns into that 500. So just like you're doing order of operations, the parentheses first turns into 500, or, and then the 200 and 200 turns into 400. Very well written 400. So we've got 500 or 400, and the way that that math goes, I've got a little bit of space here. 1 over the total resistance is going to be equal to 1 over 400 plus 1 over 500. Least common denominator of 400 and 500 is 2,000. That would be 5 over 2,000 plus 4 over 2,000. So it's going to be 9 over 2,000. The total resistance is going to be the reciprocal of 9 over 2,000, which is 2,000 over 9. 1,000 over 9 is 111.1 repeating. So this is going to be 222.2 repeating. Final answer of 222.2. There is so much math you can do without a calculator. Sorry that I don't have mine charged. Anyway, so 222.2 repeating. I'm going to do one more, and then I think you would have seen enough diversity to be able to handle a novel problem. Here we go. Fun. Okay, let me label these with some numbers. I think I can go, let's see. I think I might go beyond my mental calculation abilities on this one. So I got 40 on the left. The two in the middle are 20 and 30. And this last one can be 60. So if we were to phrase this grammatically, I would call this 40 or 20 and 30 or 60. Okay, so I think it's fairly obvious from this that we have three possible ways to go, and one of them just happens to have two resistors in it. So we had better add those two together first. So we can take this and redraw it. I'm just going to redraw that group. This group turns into three branches. The one on the left, still 40. The one on the right, still 60. But that one in the middle, made of the 20 and of the 30, well, let's just call that 50. So it's 40 or 50 or 60. Okay, so we know how to add up two resistors in parallel. How do we add up three resistors in parallel? Well, just like when you're doing algebra, let's say I know how to do A plus, sorry, let me say I don't know how to add three numbers. I only know how to add two numbers. Well, it turns out that you can still do it. You just have to be creative. So, for example, if I were to cover that, it's A plus something. Well, that's two numbers. Just whatever number is under my thumb, I just have to use it there. So, oh, I see. B plus C was the number. If you just do B plus C first, then you get a number to put into that addition. If I lost you there, don't worry about it. I'm going to come back to the real problem. So you got 40, 50, and 60 in parallel, and you want to try to figure out how to add them up together. Well, what you can do is just ignore one of them for a second. Do that 40 and 50. If that 40 and 50 combine together and I can replace them with one resistor, then that one resistor I've replaced them with will be in parallel with this one. So that just looks like this. If I combine the 40 and the 50, looks like this. 1 over 40 plus 1 over 50. That would be 9 over 200. Take the reciprocal, it's 200 over 9. That is 22.2. Oh, I just did a problem like that. So 22.2 means, I'm looking at this now. I guess I don't really have a color for that. 22.2 on the left, that's the 40 and the 50 replaced with 22.2. And then the one on the right is still 60. Well, see, this is just marvelous. Because if you want to add these two up, do you know what you have to do with them? You have to take the reciprocal, which means that this 200 over 9 turns right back into 9 over 200. That was just this, which means you could generalize this. If you have 3 resistors in parallel, 1 over total resistance is 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor plus, and on and on and on. So this whole thing is 1 over 40 plus 1 over 50 plus 1 over 60. Take the reciprocal of that. That one, I'm going to call it quits on mental math, and I'm going to open up a calculator so I can do that one. So you can obviously do this with a calculator yourself so that you can see what I am saying, but I can't put this calculator on screen because it's not my phone that I can fit underneath the camera. So 1 over 40 plus 1 over 60, I'm sorry, 1 over 40 plus 1 over 50 plus 1 over 60. 1 over 40 is 0.025 plus 1 over 50, which is 0.02. I should have 0.045 plus 1 over 60. That's repeating decimal. That should be 0.016 repeating. So when you add up together a 40th plus a 50th plus a 60th, I get 0.0616 repeating. And now I just need to flip that. I get 16.2. 16.2, which of course is less than that, right? So 16.2 is the final answer I get for this. Okay. How to proceed from here? So if you have some complex arrangement of resistors, in order to calculate its equivalent resistance, you need to interpret whether resistors are in series with each other or in parallel with each other. You can treat parallel arrangements like or. You can treat series arrangements like and. You want to replace pairs or groups of resistors with equivalent resistances so that you can get it down to one resistor.